Hey tens, Ellipsis here. Today we're going to learn about piecewise functions. Some terms to know. A piecewise function is a type of function where multiple rules are applied to certain intervals. Now, a normal function, like you've seen before, would look something like this. Y is equal to 2x plus 5. And that's normal, right? What this would mean is that for all real values of x, y would equal 2 times the x value plus 5. And this is going to apply to all real values of x. So the graph of this would go on forever. But what if I wanted this on a certain interval and not for all real values of x? What if I wanted this to be only some part, and then another rule for the next interval, and so on in this fashion? Well, that would be a piecewise function. So an example of a piecewise function would be, let's keep this one, y would be equal to 2x plus 5 only if x is less than or equal to 6. And then a second rule or a third rule or however many rules you want to add, it would make it a piecewise function. So let's just add another one for an example. Y would equal x squared if x is greater than 6. So here we have two rules. For the intervals of negative infinity to 6, and 6 will be included in that set, y is equal to 2x plus 5. That rule applies when x is less than or equal to 6. But when x becomes greater than 6, for example, if x were 6.0000, and you can add as many zeros as you want, but if there is even a slight one, there is even one, then it will change to this rule. So today we're going to learn how to evaluate piecewise functions from an equation and a graph, and we're also going to learn how to graph piecewise functions. And I personally found this very confusing when I first learned it in Algebra 1, but in Algebra 2, I suddenly got it. For some reason, it wasn't as chaotic as I thought it was back when I was learning this for the first time. So let's see how to evaluate piecewise functions. Well, if we want to do that from an equation, then we have to plug in the given x value into the rule given for the interval it belongs to. It's just like normal functions, really. It's only like a bunch of different equations smashed into one function. And then we just evaluate the equation to get the corresponding y value. So that's pretty simple, and we're going to do this in the next slide. But let's see how to do it from a graph. How do we evaluate piecewise functions from a graph? Well, again, it's like evaluating from a function, a normal one. So from a graph, we just find the given value on the x-axis, find the place where it meets the function, and the y-coordinate will be the corresponding y value. It's that simple. We also evaluate functions, like normal functions from a graph, exactly like this. So it's no different. So let's do it. Let's evaluate piecewise functions from an equation. So we have to evaluate both of these when x is equal to 2. Okay, so let's see this one. Y is equal to 2x plus 1 if x is less than or equal to 5, and y is equal to x squared if x is greater than 7. Okay, so which interval does this belong to? Well, let's find out. If 2 belongs to this interval, then this rule will be applied. If 2 belongs to this interval, this will be applied. So which one does it belong to? Well, let's use a number line to find out. So I'm just going to draw this number line and label it. Alright, so I have the number line labeled, and our target is x is equal to 2, so that's here. And let me just do this in a different color. Let's take this one. If x is less than or equal to 5, so let's do that. With the less than or equal to sign here, we need a closed dot on 5, and then we go this way. And if you don't know how to graph inequalities on a number line, I have another video that shows you how to do that, and I'll put it in the card above. So wherever this points, we go that way. And x is greater than 7. So since there's no equal sign here, we put an open dot, and it's pointed that way, so boom. There, we have our piecewise function graphed on a number line. Really, it's that simple. So let's see, where does our evaluation value fall? Does it fall in this interval or this interval? Well, if our evaluation is in this one, then it'll be included. And it seems it is. So 2 will be in this interval. So we're going to follow this rule. So let's plug in 2 into 2x plus 1. So 2 is x. Two times 2 is equal to 4, plus 1 is equal to 5. So our evaluation is 5. Pretty simple, right? Let's try the next one. Y is equal to x cubed if x is less than negative 3. Y is equal to x if x is equal to 4. And y is equal to 3x minus 2 if x is greater than 4. So let's plot these on the number line again. So we have this. And let's label that. Let's put negative 3 here. Okay, now let's label them. Let's graph this. So x is less than negative 3. Since there's no dash underneath, we're going to have an open dot on negative 3. And it's pointing this way, so there. Then x is equal to 4. We just put a dot there. And if x is greater than 4, there's still no dash, so we put an open dot. I'm just going to do this above so that you don't get confused. And it goes this way. Okay, so we have all three plotted. And does 2 fall in any of these intervals? So our evaluation is here. And no, it seems like none of these include 2. So what we have is no solution. Boom. Not too hard, right? Well, I have no idea how I found this really hard, but I hope you get this. So let's move on to evaluating them from a graph. So let's see. Evaluate when x is equal to negative 3. Okay, let's take this first one. And before I show you the solutions, I encourage you to pause the video and try them out on your own. Alright, I'm assuming that you've tried them out, so let's do the first one. Okay, let's find x is equal to negative 3. And again, these are going by ones. So, this is negative 3. And let's go up to the y value. So, we go here, and look, our y value is 1, as this is negative 3, 1. So, our evaluation is 1. Pretty simple. Now let's do this one. Again, we're evaluating for negative 3, so let's find that on the graph. So let's do that. This is 1, this is 2, this is 3, this is negative 1, negative 2, negative 3. Okay, let's search for a y value. It seems like there is no y value here. So our answer is no solution. Alright, let's move on. So how do we graph piecewise functions? Well, we mark each interval with an open or closed dot based on what the symbol says. Again, it's like graphing the piecewise functions on the number line, like I showed you when we were evaluating piecewise functions from an equation. So that's what we do. And then we graph the line following the respective rule of each interval. So let's try the examples. And again, before I show you the steps, I encourage you to pause the video and try it out on your own. But if you don't get it, that's alright. I'm gonna show it to you now, and you can try the second one after I show you the first. But for now, see if you can do them. Alright, I'm assuming that you've given them a go. So let's take the first one. Y is equal to 2x if x is less than or equal to negative 2. Y is equal to 4 if negative 2 is less than x is less than or equal to 1. And y is equal to negative x squared if x is greater than 1. Okay, so let's take each rule and graph them. Now, the difference between graphing a piecewise function on the number line and on the coordinate plane is that with the coordinate plane, you have a second dimension, the y-axis. So you also have to take that into account. So when we're plotting x is less than or equal to negative 2, we would put it here on the number line and put a closed dot. But we can't put it here because that's the wrong coordinate. We also have to take the y-axis, right? So what we have to do is we actually have to plug in this x value for 2x. So whenever you have a rule that you want to graph on the coordinate plane, you have to take the minimum or maximum values and plug them into the rule so that you'll get your starting or ending points. So let's do that. Negative 2 plugged into 2x. X is again negative 2, so we plug that in here. 2 times negative 2 is equal to negative 4. So our starting point is actually negative 2, negative 4, which is here. And let me grab my pen. So this is negative 2, negative 4. Okay, Now we have to graph this. And how would we do that? Well, we would draw the slope. And the slope of it would be 2, but since we're starting at -2, it would actually go down here. So our graph of 2x here is going to look something like this. Boom. And it goes on forever because the interval is -infinity to -2. And so let's take the second one. Y is equal to 4 if x is between -2 and 1, including 1, but not -2. So we have to put an open dot at -2 and a closed dot at 1 because of the dash here and no dash here. So let's do that, but again, it's not a number line, so we have to take the y value into account. And when we plug in these two values for the rule, well, y is equal to 4 for all of it. So we put an open dot at -2, 4, which is up here, and a closed dot at 1, 4, which is here. And then we connect it using a line because that's how it would be. Y is equal to 4, the normal one, would go all the way across and forever in both directions. But it's only over this interval, so that's what it looks like. And now the last one, -x squared if x is greater than 1. Okay, let's plug in 1 into this rule. So 1 squared is equal to 1 times the negative is -1. So we put it at 1, -1. And again, there's no dash here, so it's an open dot. But this can be very confusing to graph without a table, so let's make a table and plot some points. So we already have 1, -1 as our starting. So let's plug in 2. For 2, we would have -4, since 2 squared is equal to 4 times the negative is -4. And again, it's only for all values above 1 and not including 1 because of that open dot. So we cannot have -1 because that would follow a different rule, if you get my meaning. So let's put 3. 3 squared is equal to 9 times the negative is -9, and so on. And since we don't have enough room for this one, we're just going to go to -4. So let's plot that. 2, -4. And it's actually supposed to go this way. Okay, there we have it. That's the graph of the piecewise function we saw above. So if you get this, go ahead and try the second one, but if you still need some help with that, you can go ahead and watch the second example, which I'm going to show right now. So I'm going to give you some time to try the second one and see what you get. Alright, let's do this one. Y is equal to -2 if -4 is less than x is less than 3, and y is equal to -4 if x is greater than 3. Okay, this is a lot simpler than that one, which had some confusing stuff like quadratics. Yeah, you don't need to worry about that right now. So let's do this. Let's take the first rule. -4 is less than x and x is less than 3. Now, since y is equal to -2, it's going to be -2 for all x values, but in this case, it's only going to be for this interval. So we put our starting points at -4, -2, and we put an open dot because there's no dash, and 3, -2. So you put an open dot here. And then we just connect them because this would normally be a horizontal line. Now let's do this one. Y is equal to -4 if x is greater than 3. And since it's not including that, we just put an open dot at 3, but we plug in this into the rule and we get -4. So we put it at 3, -4, which is here. And since it's all values greater than 3, we just put this here and an arrow to symbolize that it goes on forever in this direction. So that's all. I hope this helped you understand, but if it didn't, that's alright. Go check out the enrichment resources down below and see if those help you a little bit too. But thanks for watching. If you liked this video, or as I told you before, this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, please put those in the comments below. And remember, the comments section is the equivalent of a class discussion, so if you have any answers to any of the questions, you can answer them. If you have any suggestions as to how I can improve my future videos, or even on what I should do next, please put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one!